Okay, thank you, Donna. Okay. Good afternoon. This is Surabhi Joshi, Coordinator and Advisor to India Project. And it gives me immense pleasure to welcome you all to this concluding webinar on our webinar series on E3 India models. We had some discussion with our participants, and we decided to keep this last webinar as a purely hands-on session for you to really dig into the model, see how it works, and I really hope you'll find this session to be useful to you. Now, I have with me today's key presenter, Unada Chapracha. Unada is the Principal Economic Modeler at Cambridge Econometrics. I also have with me Ranjit Dharwekar, India Program Director, Regulatory Assistance Project. And we are also joined by Donna Brutkowski. Donna is with the RAP communication team, and she is helping us with the GoToMeeting administration. Thank you, Donna. So I'm going to give a brief introduction for the key speaker, and we'll start with the session. Now, Unada Chapracha is the Principal Economic Modeler at Cambridge Econometrics. She has over 10 years of experience in development and application of these E3ME models, as well as custom-made country-specific E models for India, Brazil, Kosovo, and the US. Her recent E3 India modeling contributions cover a variety of topics, including energy and resource efficiency, carbon and energy taxation, regulatory standards, environmental tax reforms, circular economy, collaborative economy, carbon leakage, and water tax adjustments. Now, I would also like to add that Unada is one of the key persons who has developed this model and played a very instrumental role in bringing this model together. So I really hope you find this session useful. Unada, the stage is now yours.
Thank you, Surabhi, for that introduction. So as Surabhi was saying, that this session is going to be purely hands-on session because we have done 3 previous presentations on the model. And from that, you only see a glimpse of the model itself. So let's go through the model today. I'm hoping that you all have the software installed on your C drive, and this version, the latest version, has been uploaded a couple of weeks ago. So if you don't have the latest version, please go back and download the model from our model website. Yes, so today the objective is to show you how to run the model baseline, and I will do 2 example scenarios. These are parts of the testing scenario that come as a default with the model that you download. And all of these today, that what I'm going through, is already recorded in the document that comes with the model, called user guide and test scenario. So please do not worry too much if you don't follow, because we only have 1 hour. I don't think I can stop and help everyone live. So just bear that in mind, and yeah, and let's go through it. Hopefully by just watching me doing the modeling live will give you some sort of more confidence to go and spend your weekend playing around with the model, for example. Okay, so once you download the model from the website, if you can save a folder called E3 India to a local drive, so in this case I save it into my C drive, and if you open up this folder, you'll see that there is a shortcut to the software itself called Manager executable here. If you don't find it in here, the actual software is stored under the Manager folder. So let's just double click that to launch the software. Now, we have said in our installation guide to say that the model works best with Google Chrome. It also works on the latest version of Internet Explorer, Edge. But I recommend using Google Chrome as a default. Okay, So when you first open up the model, you have various tabs, and I will go through these in detail. However, to save us some time, I would quite like for us all to go and run the baseline model, because it takes about 5 minutes to run these, and I don't think we just want to wait around and wait for it to finish. So if everyone is with me, let's go to the Running the Model tab, okay? And you will see that there are 3 key inputs to the model, and we just need to give an output file. So we'll go through these input in details, but for now, if you can follow me and type the name of our baseline here. Okay, it can be any names that you want. This is the name of an output file that after the model runs, it will get saved accordingly as a text file. So in this case, it will call a baseline text file basically. And once that's ready, just click on Run the Model. Okay, and you'll see that it's starting. Right, I'll come back to these. If everyone else hopefully is already have these model running in the background as well. Okay, right, let's go back to each of the tabs. So we have the introduction page, which we contain information about the model and version. So this is the final version. We'll say it's final, but we are also developing it all the time. So we have to start giving it some version name at some point. But yeah, so as it stands, this is the final version. Okay. Then we have a tab called Model Data Bank. So we start to go through different input now to the model. The Data Bank tab is currently empty. Eventually we'll hoping that the data bank, this is where we contain all the model historical data and the projection for the baseline forecast. It contains a lot of 3-dimensional variable to the model. Eventually, we're hoping that we will develop a system where you can directly make change to these data in the data bank, but currently it's not available. What's available are what we call an idiom instruction file. Now, you will see that to run a baseline, we have selected N forecast, which is highlighted in the dark blue column. So this is our main default baseline idiom instruction file. So in itself, the model baseline does not contain any policy inputs. So it's simply a projection using the econometric estimation from the past historical database and the calibration to the published forecast. In this case, we use the India projection as a whole and apply the growth rate to all states in the same way, because we do not have better information on state level forecasts at the moment, but the model is able to do that. Okay, so the idiom instruction file contains reading command from model data bank to do basic operation and get derived variables, for example, just simple plus and minus, or doing division to get to current price, for example, constant price. So if you're looking at the script, there's a lot of get command of data from the data bank. So you might find this a little daunting, but rest assured that all it does is simply do the initialization of the model variable containing reading command and setting dimension of model variable. However, because this is a place where we're reading in data, including the projection that we want to calibrate to, it's a place that we can also make a direct change into here. And you will see that in one of the examples that we do is to introduce exogenous change to investment. Now that variable contains three-dimensional variables, so you can imagine it's by state and it's by sector and it's by term. So we don't really have it set up in a way that that is just basically a two-dimensional spreadsheet of all these variables. Instead, what we did is we store it in a data bank, and because it's on the data bank, and this is the place where you read variable from the data bank, you can make change directly into this file. And actually, the change, the line of code, requires some knowledge of programming, but you will see if I show you that it's not complex at all. It's just a case of being able to identify let KR, which is our investment, equal to some number, some millions of rupees. You just have to give it the dimension for the sector that you want to do, and the region that you want to do, and the year. So, for example, you might have a line that say if year equal to 2020, let KRX equal to 10 billion of euro, for example, and that is all you need to do, just one line of code. Okay. But that's the one group of the input file. Let's hide this group for now, and you see that we provided 4 separate test scenarios. How this related to our test scenario is summarized in the Model Manager User Guide. Here, I think, yes, here. You'll see that we provided 11 different test scenarios, and the 3 key inputs are the idiom instruction file, the assumption file, and the scenario file. So the idiom instruction file is the first column here, and you see that in scenario 1, test scenario 1, you just have to make change from end forecast to end test 1 and set the model to run in order to run this change in exogenous investment. For more detail about what this scenario 1 actually is, then you go to another document that comes with the model, and you'll see the specification in detail. Basically, scenario 1 is where we increase exogenously investment in sector 18 for all regions. Okay, right. So that's where you map all the information together. But let's go back to the software. So that's the first set of input. The second set of input are what we call scenario files. The scenario files contain common policy, as I was saying, because in the baseline we don't assume any additional policy from the historical data and whatever the calibration projection that we're trying to calibrate. So anything on top of that, the policies that are commonly used are stored in the scenario file. So in this case, we have an option to enter energy tax. So we have the tax rates, rupee per ton of oil equivalent, but also all the dimensions. So we can do an energy tax, carbon tax. Now, because these again are 3-dimensional variable, because you can apply, say, energy tax to different state at different rate in different time periods. So you might want to increase it gradually over time, but you might also want to only apply it to some of the sector in one particular state. So you might only want to apply to the electricity used by household in state 1, but not in other state. Okay, so we also have the fuel dimension and fuel user dimension. So this is how it gets complicated, and this is why we can't make all the model input variable in this way. In this scenario file, we only contain the commonly used one, which is energy tax and carbon tax, and some revenue recycling option. Okay, so you can see that the energy tax scenario file only contain two dimension because this is how we can display here. So this is by region and by term. Now, if you want to set that to be more specific to different user of energy, this is where the switch are coming handy. So at the moment, the default is all zeros. So it means that when we do have an energy tax rate applied in rupee per ton of oil equivalent, we need to set the switch to 1. And this means that if you put in 1 for, say, household in the AP state, then all that rate that we set in energy tax, we only get applied in Andhra Pradesh in household sector, and all the other sector will not be subject to tax. Now, if we do that, it still means that household use of all energy type is still being set to subject to tax. So household use of coal is still subject to that tax rate. Household use of oil, gas, electricity, and biomass are also are being subject to the tax rate. So yes, we need to only set it to electricity and set other to zeros if we want that scenario to be just household electricity in Andhra Pradesh. Okay, but again, that's just an example. Then we have different options to use revenue from carbon and energy tax to reduce employer social security contribution, direct tax, and VAT. So the model can automatically collect all the revenues for recycling. Now, what I forgot to mention is this number doesn't have to be 0 or 1. It can be 0.5, so that only half of it is covered. Okay, half of the revenue get recycled this way, or if you want to split it 3-way, you can do a third each, so that's okay too. And you can make change directly to this number here, as you can see, but this is our baseline, so let's not default scenario file, so let's not save that. Okay, what you would want to do is to duplicate it first and then make change and then save. And again, we have provided you with 6 different scenario files. And again, you can refer back to this table to find out what. Can you hear me okay now?
Yes, I think everyone
Okay. Okay, so that's the scenario file. The last set of model input are grouped under assumption file. Okay, assumption file contain model exogenous variables. So slightly to policy, these are the exogenous variables, such as population growth, government fiscal policies, and also global assumption. So if we look at this file again, we'll see that we have a different heading, and I think this is all explained in the what these are in the model manual and in the user guide. But at global level, we have assumption on commodity price, the food, feed, wood, construction mineral, industrial mineral, ferrous ore and non-ferrous ore, as well as international energy price. We treated these as exogenous because we only run India as one single country, so no feedback from international oil demand and supply. So that's why we have to enter these energy price as exogenous. Otherwise, we also have GDP assumption for India main trading partner, and this will affect the export demand for the India model. So if we change, for example, US GDP growth rate, then we should see some result coming through in the E3 India model export equation. Okay, so the last tab before we go into the run the model and model result is the variable tab. The variable tab contains all the variable name, description, and unit for your own reference. It's just a list. However, if you're not sure of what you're looking for, you can always do a normal find using the browser find option by clicking Control F. This should bring you up a find box, and for example, if you want to look up the GDP variable to look at the result, you can then see that it's called RGDP. Or if you want to search for, say, consumer spending, so you'll see that what variable are there that are related to consumer spending. Okay, right, so hopefully now we can go back to the running the model tab, and we should see that it's finished. So so when it's finished, it should be green and said all done. But let's just stay on this page for now. Okay, so when you make a new file, like say new idiom instruction file, or create new scenario file to use for your scenario, this will automatically appears under this list. So you just have to choose it basically to run that scenario using the correct input that you set up for this particular run. The assumption file as well. So it could be that you just only want to change one of the input file, like the idiom instruction file, but other things like the assumption files and scenario file remain the same as default. And when you want to run it, you will have to change the name accordingly so that you can keep track of what these scenarios are. But the default are end forecast, assumption, and base spend that we just ran. Now, when you select different file, you'll see that these three next box get automatically updated. These are basically what we call a command line. So when you run the model, essentially what it does is run the model executable, and these are the result that basically appears in the normal command box that we showed you. We moved it to one single place, so instead of for you having to open up a separate command prompt, it just shows summarizing the result here. Now, I have speak previously about what these are. So these are not the result by any means. It just shows the progress of the model solving year on year. So the model solved for 32 regions, yes, and these just show you a summary of year-on-year growth rate, so that you know that the model is progressing. There isn't an obvious crash. So if there's like a massive jump in these growth rate number, then you'll notice it very pretty much straight away. Over historical period, you can see that the growth rate are a lot more volatile, but that is coming straight from the data. But over the projections period, it should be a lot more stable. Okay, different tab. If you want to know what these are, so the date is quite self-explanatory. So when you solve, it's solved each year, and last year had feedback to the current year because the model is relying on the dynamic interaction. We have the number of iteration. We have a column for CO2 summary, and this is in level in gigaton rather than in the growth rate. And then we have the GDP growth rate, total consumer spending, investment, export, import, industry price, consumer price, export price, import price, wages level, again year-on-year growth, trade balance, public balance, and unemployment rate rather than growth rate. Okay, so that's pretty much it. So it ran all the way to 2035 and it's finished. Now to look at the model result, we should go to the model result tab, and you will see that currently there's nothing here. This is not because you did something wrong. You just need to click refresh so that it can go and look for any file that has been saved into that particular output folder. Okay, so now we'll see that we have, when we run the model, we gave the name for the baseline run as the simple baseline, and that's .mre is a text file extension So when you click select on that, and if you click on enable front end, you'll see that we now have a lot more option to display the result. So, but because we only run the baseline currently, we only have one file to look at, but that's okay. So if you click on the baseline to highlight it, and then you'll see within here there are a lot of variables that that appear on the variable tabs. So we can click, for example, on the first one, consumer expenditure, because this is a three-dimensional variable. So you have consumer by state. So we can select, say, the first state, and by different consumer spending category. Then we click on different. Well, I click on all sector, but you can also click on individual ones, and you'll see this is the over time our projection and over some of the historical period. Okay, so number one is food, so we're projecting it to increase with trend, and other sector accordingly. Now, if you would like to do a summary across dimension, you can do that. Simply select sum these and say if you want to sum across the first 8 states, then you can. This is automatically updated and recalculated for you. Or simply for India as a whole, you just click on all dimension, because we're summing across 32 states. It should be equivalent to India total. Or if you want India total only for food, then you can select that. Or if you want India total for first 9 consumer category, then you can do that, and that's automatically recalibrated for you. So hopefully you'll find it quite quick and responsive. Now, other changes that you can do with this software is probably more suitable when you'll be looking at comparison between the 2 files. So we'll do that. But otherwise, if you want to show table of data, you can select tick that box to show table of data. Now, this can be copied directly to Excel by just highlighting and copy. Otherwise, you can click on download a CSV, and that should automatically take it to CSV file for you, okay, that you can then use for further manipulation, or you want to do a different type of chart, for example. And that's not necessary because we're selecting some of these. So if we don't sum it, now the table automatically updated for you as well, and the export to CSV will be automated. So yeah, so the software itself is quite quick and responsive. Fine, so that's just the baseline. So even if you just want to looking at data and explore different model variables, so we have different group. We have economic variable. We have energy use variable. We have the power sector variable, and we have emission variable. So you can investigate these individually, and that could take you all days if you like. But to us, it's more interesting when you start looking at the scenario and comparison it to the baseline, which is what we have here. Okay, so let's run our first scenario. Okay, so I'm gonna show you one of the test scenario that come with the model, which is a simple carbon tax scenario where we apply 400 rupees per ton of carbon. Okay, note that it's per ton of carbon, not per ton of CO2. The model unit for CO2 is tons of carbon. So, so what this means is that what we did, 400 rupee, is very, very small, right? So just to bear that in mind. And the test scenario here is the test scenario 2. Sorry, not test scenario 2, test scenario 4, carbon tax, and this give you the explanation if you refer back to this this document. Okay, so but the input file that we're putting in is called send to, so it's come under scenario file where we have the carbon tax option. And for now, we only set it to apply to all fuel user and all fuel types. So everyone is subject to this carbon tax. Okay. So essentially, all you need to do is to bring up scenario 2 in the scenario box list, and to give the name of the output file that is kind of like understanding to you and something that you can refer back to, because if you only give it something like S2, you might not understand what it essentially is when you come to comparing the results. So put something that makes sense. So I could put in a carbon tax. So we know that this is an output of a carbon tax run. Please note that you can't have space in the name. So if you want to space, just have a underscore or something like that. Okay. Now you can click on Run the model, and this will again run in the background. It will take about again 5 minutes. So to maximize the time while this is running, I just want to go back just to show you where these files are stored in the actual model folder. So the manager software brings together all the model input to one place, but essentially all these inputs are a text file basically. So if you click on these, now you'll see that this is where the idiom instruction file are stored, n forecast test 1, 2, 3, and 4, and in the scenario file 1, 2, 3, and 4, 5, 6, and in the assumption file is 1 and 2. Don't worry about other folder just now, okay? Now, I highly recommend, once you get a bit more comfortable with the model, you might find actually editing input in the software itself is a bit restrictive. Some people like to work with Excel. Some people would like to do other manipulation, because the manager software input, you can type in the single box, but it could be very time consuming if you have very complex scenario run, for example. I have previously give out a document recommending how you would do this using a text editor. So for us at Cambridge Econometrics, we use a freely available software called OxEdit, and that can be downloaded through this link. Now, I'm not sure if everyone have access to this document, but I can ask Ravi to pass it around after the presentation. And that will send you to the link to download this software. Okay, but it doesn't have to be this. It can be a Notepad or Notepad++ or whatever you're comfortable working with. Okay, and this also show you, well, I will show you very quickly, but this document will be able to tell you how to use the text editor outside the manager software once you become a bit more confident in setting complex scenario file. Okay, so when I have my OxEdit here, this is a default that it will open it with. So for example, if you're looking at the scenario 1 files, double click on it. This is the same list that you see in these files. So scenario 2, show script. So this is scenario 2. So we want scenario. Yeah, so we want carbon tax. Okay, so yeah, so 400. This is exactly that scenario 1. Sorry, I'm lost myself. So it should be scenario 2 for carbon tax. So you see that it's exactly the same, apart from this is just a text file that is gets separated by, if I can show white space, a space. Okay. Now, so if you want to change this, we don't have to show space now. You can just simply copy this to Excel. See, you can see, and then we do the normal data text to column. Okay, and then we can change here. So this is when you start to get complex if you want a different rate for each country over time. Say if we want to grow it with inflation, say for example 2% a year, just for the first one, for example. So we can use Excel very easily to editing these input. Okay, let's just reduce the number of decimal point for tidiness. Okay, so you can see that now it's no longer all 400, for example, it's 500 and growing with inflation. Now what you can do then, once you finish manipulating it from Excel, is to copy it back and paste it here. Okay, now with the use of the text editing software, you can see that the spacing is now a bit funny, and the model is very particular about spacing. So we go by space again, and you see that it's no longer a space, it's a tab, but we can easily change that using just doing find and replace. So we can do, again, these are all documented, so don't worry about following me, but I just want to show you the flexibility of it, okay? Okay, so now we can save this, and now we have very quickly make a scenario a lot more complex by setting a different rate for the first region, and it can be any other dimension. So that's the use of the text editing software when you feel like you want to have a really complex model setup. And yes, and so hopefully you'll see the flexibility there. And it's the same with the assumption file. If I open it up just to show you again, it's simply a text file that you can make change, and you can use the same facility in Excel to copy and paste back. Okay, and what's good about the text editing software as well, some of them you have an ability to do the difference between the two files. So you'll see exactly what are the different here. So in this case, N test 1 is the place where we enter exogenous change to investment for sector 18 in all state by 10% of the existing investment level. So this is just to again show you how simple one line of code it is, that you can set up a scenario and that give you a 10% exogenous increase in all states. Okay, so don't be daunting by the many lines in these files. The actual line that you have to add in addition to run the scenario is only 1 or 2 lines. Okay, so let's go back to our result. Hopefully it will finish by now. Yes, it has. So yes, so we have run a simple carbon tax scenarios, and we would now like to check the result. What we have to do now is to go back and click on reload data. Reload data, which should bring up now a new file called carbon tax, which we have just run, and the baseline is still there. Now quickly going back, this gets stored in the output folder of the model. So this is where everything comes together. The software manager kind of like bring together all the elements of the model input, basically. Okay, so, and if you are also a confident programmer, you can use these massive files, read it into a separate software that you have developed, for example, using MATLAB program code to do a lot of manipulation, you know, of the data, the result that come through here. This is how we do it here at Cambridge Econometrics. We print out the model result, we create a software, and then we're printing out the result and table for the report using our own software. Okay, but for checking the result, definitely we go back to the manager software and do that. Now, in this case, you would like to highlight 2 files to be able to compare. So we want to highlight the baseline, which is what we're going to compare our result against, and the carbon tax scenario that we just ran. Fine. So again, remember to highlight these 2, because otherwise it won't show up in our result. Okay, and you can select which baseline do you want to have, but in our case, we want the baseline to be our baseline, basically. Okay, so before checking the model result, I'm sure you're aware of this already, it's good to have some sort of period expectation of the key impacts of the scenario, because otherwise we will be scoring through these variables indefinitely without having some sort of starting point and end point. Usually it's a good idea to check the input, so it was going in correctly. So in our case, we want to be able to look at a model variable called carbon tax, carbon price time theory, COP. And again, you can refer back to the variable list. So if you do Control-5 for carbon tax, for example, it should bring up the variable name that you need to search for. These names are in alphabetical order, so it's not in the same order as the one in the variable list. But so we have introduced 400 rupee for all states, so that seemed to be coming through fine. Okay, and so the obvious kind of like cause and effect, having a carbon tax should reduce carbon dioxide. That's why we introduced carbon tax, right? So we looked at first the CO2 emissions. So this is by totals, so it hasn't separated to different user. It's just a total for each state. So if we select on all sector, it's not very useful because it's just two levels very close together. Remember that the 400 rupee per ton of carbon is very small, but we can do a relative difference, for example, and sum this. And you see that, you know, with 400 rupee per ton of carbon, and the result is approximately 1.2% from the baseline. Now that's not too bad. So that's what we see coming through. Okay, so that's carbon. What about, you can look at carbon dioxide result by different users. Again, it might be best just to sum all this. So you can see for the power sector, was most responsive, manufacturing and other sector, there are some sort of rebound effect towards the end. And again, you need to remember that because we put CO 400 rupee as a same rate over time, so actually in real term over time it becomes smaller. Okay, so the best when you type in a tax level, you need to take into account of the inflation because it's in a current price. But anyway, so that's the CO2 result. Now, what happened in the power sector then? Okay, so let's have a look at power generation, for example, MEWG. Again, let's keep it as India as a whole because otherwise we'll be clicking through everything. So for all sector, oh, there is an increase. Now, you might question why is there an increase in power generation in total? Well, because the model takes into account of switching between final use. So the carbon tax is applied to all energy and all user. So ignore power generation just now, but for final use, I say from household, switching from oil to electricity is one way of mitigating from CO2. So the carbon tax has that effect, making coal more expensive. Okay, so that's why we see slightly higher demand for electricity because of that, and therefore the total generation is slightly increased. But within power sector itself, generation increased for most of the non-fossil fuel types. So coal reduced, yes, that's what we want. The carbon tax have an impact on coal power plants. Gas actually increased because for us in the power generation, switching from coal to gas is one of the first result, if you like, that we see coming through, because gas is still relatively cheap compared to other type of renewable, and it's less carbon dioxide intensive. So switching from coal to gas is some result. Sometimes we see when we put in small level of carbon price, okay, but when we put in a very high carbon price, then we should see gas technology to decline as well. But otherwise, moving to renewable, we see that Okay, there's a small increase in large hydro, but onshore there's quite a big stimulus to onshore technology from carbon tax, and also in solar is quite a big change. However, you must remember that our baseline solar in level term is still very small compared to coal and other things, so it still remain a minor technology at this point because of the low carbon tax. But yeah, we have run many example scenario now where we really push for solar and wind, and we haven't introduced any power sector specific policy. So if we want really to promote renewable, we can also do carbon tax, but at the same time bring renewable subsidy or feed-in tariff for this, and we should see a lot more take-up rate coming as a result. Okay, so that's it on the energy and on the power sector side. What happened to the economic result? So the first go I often go, which is probably not the best, is in GDP, and then I try to explain later through the component of GDP what causes this. Now, it was surprising to me at first to see that GDP effect of carbon tax is slightly positive. Now, it's very small, so 0.3%. However, when I start looking at the component of GDP, I can see clearly why this is the case. So yeah, so the component of GDP are consumer spending, investment, import and export is the main one. Now, one would expect carbon tax increasing costs, and therefore lower household spending, higher inflation and lower household spending. Yes, that effect is coming through. So if we go to PRSC, for example, now this is an index, so when you sum it together, it's not quite the right, it doesn't do weighted average for you automatically, but you see that average price do increase, okay? What happened is, so consumption should also decrease because of price, yes, and we see that. But what happened is, when we're looking at the investment, we see that this effect actually a much larger scale, so 1.2%, than other component of GDP. Now, this investment, I just know that coming straight from the power generation. We're just looking at the power generation result, and there are new solar and wind technology taking off, and that's coming. Coming with the investment for that particular technology, and because the model is very complete, it sends the link back to investment made by the electricity sector. So number 9, and you can see that it's quite volatile, but overall you see that the increase coming from this particular sector, and that has knock-on effect on consumer spending, on employment, on output of a sector supplying to electricity, investment, for example, construction and engineering. Those construction and engineering will demand additional labor that created additional income and increase in spending. So those kind of effects are captured in the model. Okay, so that was one of the scenarios. I only have 10 minutes left. I was going to do another run, but I don't think I have time if we want to do Q&A session as well. Otherwise, yeah, so, but if you're already there, I mean, you can set that to run in the background. And the other run I was going to show you was a scenario, the same carbon tax scenario, so 400 rupee per tons of carbon, but with a revenue recycling that's automatically set to reduce income tax, and that is in the file cost scenario 4. And if you want to set it to run, so when this call is finished, you can go and look at the result to compare. So after revenue recycling, but I just do it as income. Okay, set it to run. Okay,
Okay. Another one is, as it's running, there are a few questions. Can we take a few questions now? It's like
yes, of course. Yeah.
Yeah. Yeah. I mean, the floor is open for questions if there are any.
Hello, I am Pradeep speaking. Can you hear me, please?
Yes,
Hi.
we can hear you.
Yeah, we can.
Yeah, we can hear. There were some few basic questions which I had. One is the carbon tax is applied at the end use. I think somebody having their mics on, I think, and therefore I'm getting a rebound. Yeah. If you can switch off your mics, I can.
Maybe me.
No, okay. So is the carbon tax applied at the end use, at the user end, or it is at the generation end? That was one question. The second question was the energy tax is generally in India at the on the generator. The generator may have to pay energy tax, but usually it is built into the tariffs itself. So I'm not sure whether that kind of disaggregation of information is available right now. So that was another question which I have. Therefore, when you explained about the results, I thought you were taking into consideration that the carbon tax is at the user end. Am I correct on that assumption?
Yes, so the carbon tax gets applied to, so essentially what it does is it worked out the carbon content of each fuel, and then it worked out then how to the change in the price of that particular fuel. So say in rupee per ton of oil equivalent. So it converts from rupee per ton of carbon to rupee per ton of oil equivalent based on the carbon content of that particular fuel. Now those prices get applied to the final use. You're right. So in our fuel usage classification, power generation is one of the user. Now it's not, it's the power generation use of other type of fuel in generating electricity that will get taxed as well as the final use being used by household and industry that will get taxed. So when we enter a carbon tax to all sectors and all users, that means that both power generation, what fuel used to generating electricity will also be subject to the same carbon tax as the rest of the final use.
Mm-hmm. So the user is not taxed; it's only at the fuel, at the generator.
And the user, yeah, so the end use, so like for example, household use of oil for car transport will also be taxed.
Okay, because the tax is on the say, for example, a person is buying gasoline for his car, then that gasoline is taxed when he is buying the gasoline.
That's correct. Yes.
Okay, so so this is at the distribution end.
Yes, that's right. So the end user. So what to say? Yeah, again, like say the manufacturing use of coal will be subject to the same tax. Yeah, so that's right. So the end use, except for the power generation sector is treated separately to the list of the energy use that we have in the model. Okay, so you see this list here. We have the power sector. This result is driven from our separate FTT model, which I think we have talked about previously.
Yeah.
And that's within power generation, we have these 24 different type of technologies. And when we enter a carbon tax, those carbon tax get automatically sent to the FTT model to make kind of like coal power plant, the carbon tax element get added to their levelized cost to make coal technology relatively more expensive than was in the baseline, for example. But for other type of fuel user, these are the end use, like we were saying, how the household pay for gasoline, household pay for electricity bill, and so on.
Okay, just a point of clarification.
Yes.
At this point of time, we have only carbon tax only on coal. We don't have carbon tax right now in other fossil fuels, especially the hydrocarbons.
Yes.
So it is just now just an exercise for us to understand if we have to implement it, then how do we go about, right?
That's correct. Yes. So all you need to do is adjusting the switch in the scenario file. So if you want to show script here, so as you can see that we have energy tax and carbon tax, and the two dimensions that go with each. So so for the carbon tax, we set the rate here, so 400 rupees. And currently in our scenario, in our test scenario, it gets applied to all type of fuels. Now, what you want to do is to take out, so presumably the coal carbon tax is already embedded in the baseline. We then only have to put in additional carbon tax on oil, so we would put everything else to 0. Save this and leave oil to 1. So meaning that, or the rate that you set here, 400 rupee, and now it could be any rate that you'd like to test, get applied fully to oil. Now, the other dimension that you can play with is that if this is only affecting final use, it doesn't concern power generation use of oil generation, then you just take out the power generation sector. Okay. Otherwise, if it get applied to every end use, including the power generation, you just leave it all to 1. So you see how the 3 matrix fit together. So when we worked out a carbon tax paid by a particular user by a particular type of fuels, we just take the 3 matrix and multiply it together.
Okay. Okay, maybe when I start working on the model, I'll get a little more clarity.
Yeah, so as I was saying, please just get in touch. I mean, it's quite daunting just now, and because I can't really try to cover or foresee what everyone's trying to do. But if you have some sort of scenario in mind that you like to model, you can always come to me and I'll be able to tell you very quickly how to set it up, basically.
Okay. Okay. Okay, that's the question I had at this point.
Okay, another what I would like to point out is, like, we've almost run out of time, so it would be good for us to take a few questions and maybe end the session.
Yeah.
So are there any specific queries which you would like us to
Actually, I had another question on GDP.
Yeah, sure.
Yeah. So the result when you showed about the change in GDP, there was further an increase and then a decrease, I think. So with the application of carbon tax, there was an increase in GDP, then a decrease.
Yeah. So it's a combination of things. So you'll see that the first year that the carbon tax was introduced, we see this spike, and that I think reflects purely because of the investment shock to the power generation. Because then when we look at the investment result, you'll see this jump right in the first year. Now the decrease is because the tax has becoming a bit less, and we often find that the shocks in the first year and it's slightly coming down. That's the property of the model. What we have these kind of like short-term and long-term response, if you like. But also for the consumer spending, we see that actually the initial reaction is through what we would normally expect for what the carbon tax do, which is increasing price, generate normal inflation, which lower consumer real income and lower consumption. Now that we see happening here, which I think might be explained. So it's a combination of factors. So eventually, perhaps in the early years, the first year investment effect dominates, and then the consumer spending dominates slightly. But in the long term, because of the investment, you see sort of multiplier effect, employment starting to increase because you need a lot more investment to build in these new renewable technology. So that's why in the long run, we see the rebound coming again on GDP from the effect of the investment. Okay, so overall the results are small, but if you then start tracing to these individual impact, so for example, you can go to specifically investment by electricity sector, and you'll see that the impact is much higher than that. So the GDP result is a combination of all those impact together, and it's slightly difficult to explain by simply looking at these number and these picture.
So is there a table which gives us an output of multipliers?
No, but you can test that. So the model captured these multiplier effect, but so much more, because it's all kind of like everything is connected and they solve simultaneously to get a solution for each year. So you can't quite identify a particular multiplier, so type 1 and type 2 multiplier, but also the rebound effect on the energy use would have then feedback to the economy again. So, but what we could do if you want to find out a multiplier is to just set a very simple shock to the economy. So, for example, in the shock to investment scenario, so just do 100 or 100 million rupee for a particular sector, and then you can work out the net change in GDP from there, for example.
Mm-hmm. I had another question. Maybe it was covered in the FTT.
Mm-hmm.
Does the power supply and demand always meet? I mean, are they in equilibrium?
Not necessarily, but that's only the adjustment. So it's the last year of historical data. We have the generation data, but we also have the total electricity demand, which is a final use, which come from different source. So what we did is we take the different, we convert it to the same unit and take different, and that is what we call the loss. So the bit that's A, T, and C loss, if you like, and that remained a constant ratio throughout throughout the.
No, my question was that at any given point of time, the power supply and power demand is always met.
That's correct, yeah.
Okay, they're always in equilibrium. So in the case of renewables, which only generate, especially the solar, generates only for 6 hours in a day, that is when the sun is on, then what happens to the power demand from solar? I mean, it's not, it tapers out and it's not considered?
So the power demand from solar, so the power demand doesn't get separated by technologies, okay? So only the total is met of the whole system. So yeah, so the total would match the level of, so the FTT calculate the generation that would meet the demand at total level, but where it's coming from within technology is for the FTT to decide.
Yeah, so so there are some questions in this. which I can probably ask little later, because it'll go into some aspects related to the power system. So at this point, I will not ask these questions. Maybe I'll take it up separately with you.
No problem. Okay, I see that there are some more questions in the present curve. Is it possible to come back to base price, that is blue line? Do you mean just by seeing the level? So here you see that in terms of level, it's always almost on top of each other because the chains are quite small. I think that's what you mean. Or if you just want to look at the baseline on its own, you just don't select the carbon tax scenario to display. Okay. Does that answer your question? Is it possible to come back to the base price?
Okay.
That was for whom? It was not for me, I believe.
I think there's a textbook chat that asks,
okay.
Is it possible to come back to the base price, that is blue line? So this is our baseline, so you just have to click select on the baseline only to see the result, because the two results are very close to each other, so you don't see it in level term. You can, because we select baseline as our main base to compare it to, so that's why the blue line is go to 0. So there's nothing compared to itself, no change compared to itself. We can go back to that. Okay. Is there any other questions?
Okay, so is there any other quick tip that you want to give, Nada, for the model in general? No?
I think that might be it.
Okay, so I believe we have come to the end of this session. It was a wonderful journey of 4 webinars, and I really appreciate your interest, your enthusiasm, and the fact that you gave us time to share what we are doing at this point of time. We have scheduled outreach next week, and I really hope to meet all of you and we can discuss this further. And with this note, thank you all for joining in this webinar session. Thank you, Nada, for bringing this us. Jonah, thanks a lot. Sanjeev, thank you for being here. So we meet in the outreach session now. Thank you. You would be hearing from us, and we'll be having many more webinars. I would really like all of you to give us suggestions on the type of topics you would like us to cover, so then we can customize it and maybe have separate customized sessions for anything that you feel is important and have been left over. Thank you. Thanks.